Hi, today I'm going to talk about Agile testing. Now, I'm very far from being an expert on testing myself, so what I won't be doing is telling you how to do testing and what tools you should be using. Instead, I will be talking about testing from the perspective of the Agile project manager. I will explain what are the key features of Agile testing so you know what to ask for and you know how to tell that you're getting what you want. By way of introduction, let's start with an example. Imagine that you run a small heating engineering company. And very excitingly, you have just won a contract to replace the heating in a huge office building with over 300 rooms. The only problem is, you're not allowed to close any part of the building to do your work. You figure out that, working at night, you can do one room at a time and have it all complete and ready by the time the first workers come in the morning. The first night goes as planned. You complete the first room, turn it all on and check the heaters to see whether they are working. The next night you complete the second room. You turn the system back on, check it, and then go back to the first room to check that the heaters there are still working. Now you carry on like this for a few nights, checking the new room and then going back and checking that all the other rooms are still being heated. This process of checking that the new work has not broken something that already works is called regression testing. After a couple of weeks, you realise that there's a problem looming. It's taking longer and longer to recheck the rooms that you've already done. You sit down with a pencil and paper and work out that by the time you've done 50 rooms, you will no longer have enough time to recheck all the previous rooms before the start of the next day. What to do? Well, you could cut down on the testing, but you know from your experience already that sometimes the heaters in the rooms that have already been done get airlocks, and the contract has some pretty stiff penalties if the rooms are not properly heated in the day. You discuss the problem with Bob, your partner. He has a bright idea. You could buy some remote temperature sensors and install them in all of the rooms that you've finished. Rather than having to walk around and check every room, you will be able to see whether the heating is working using a handy smartphone app. So the next night, rather than starting a new room, you go around and fit temperature sensors to all of the rooms you've already done. Works like a charm. You're now able to continue working, safe in the knowledge that you will be alerted straight away if any of the rooms you've already done stop heating. Not only that, but because it doesn't take long to fix up a temperature sensor in a room, you can get someone in to fit sensors to all of the rooms that you haven't done yet. By breaking the link between the implementation and the test, you are able to work in parallel in a way that was not possible before. Now, as we will see, being able to run regression tests quickly and to develop features and the tests that will verify them in parallel are critical to the success of Agile projects. I'll now move on to talk about projects more generally, particularly those with a lot of software development, as this is where the Agile approach to testing comes to the fore. The traditional approach to testing is very manual and sequential. A developer finishes a new feature. This is then incorporated into a test version of the product. The tester then takes that test version and presses buttons, pulls levers and so on to check that the new feature works the way that it's supposed to. If the feature passes, then it will get batched up with a whole load of other features. It is at this point that regression testing comes into play. A test product with all the new features is created and the testers check that the new features play together properly and that nothing has been broken by the addition of the new features. Now think about this in the context of an Agile project. We might be delivering a new version every 2 weeks. If we're not careful, we could end up with a situation where the testers don't do anything for the first 6 days and then work like mad for the last 4 trying to test everything before it's time to deliver the new version. We also have the problem that the regression testing only happens right at the end. If something breaks, you only have 1 or 2 days to find out which of the many added features have caused the problem. The way to get around this is test automation. If you are developing software, there are various specialist software programs available. These interact with the program being developed to press buttons, enter numbers into fields and so on, and then check that the expected result actually happens. For example, the software would check that when you selected a barbecue from a list of products, that the barbecue appeared in your shopping basket and not some other item like a hammock, for example. If you are developing products with electronics, then the testers will probably develop specialized circuits, these are called test harnesses, that allow them to send signals into the electronic devices that are being tested and measure the signals that come out. It's important to understand that there are 2 kinds of test automation systems. There are those that record what a user does, every mouse move, every click of a button and every key press, and replay it on demand. The advantage of these is that they can be used by testers with relatively little extra training. The tester is essentially doing manual testing, which is recorded and then can be replayed many times. But the disadvantage of these tools is that they're incredibly fragile. The developer only has to change the position of a button even slightly and the test will no longer work. And it's the fragility of these kinds of tools that has given test automation a bad name. The other type of tool requires the tester to write a script for the tool to follow. The test script will have instructions like, for example, click the button that has an ID of submit. Check that the value in the field named total is £200. The advantage of these kinds of tests is that they tend to be much more robust. As long as the developer doesn't change the name of the submit button, it doesn't matter where it is or what it looks like. It's also much easier for testers to create a lot of similar tests. Once a test that checks for a total of £200 has been created, it's really easy to copy it and make a test for £1 million or -£5. There are 2 disadvantages to these kind of tools, however. Firstly, to get the best out of this approach, it requires developers to change the way they do things. Secondly, this kind of testing requires a developer mindset from the tester. Now this is harder to recruit for and it's more expensive than traditional testers who are often converted users. However, once the team has made the leap to automated testing, then a whole load of other advantages become apparent. A developer can run all of the tests against their own development systems. Now this means that they can perform the regression test before they pass the new feature onto the tester. A tester can develop the test before the developer has finished the new feature. They can deploy the new test into the test environment and all that will happen is that the test will fail until a test product is created that includes the new feature. The most important advantage is that this approach forces the developer and the tester to have a conversation about what the new feature should do. Any disagreements about what it means for a feature to be done can be discussed and can be agreed with the product owner before a lot of time and energy is wasted. So, as an Agile project manager, what should you be looking for? Well, a good team will have a lot of automated tests. All of the tests should be run against a test product and this should happen at least once a day. There should be a culture within the team that failing tests are unacceptable and that they are fixed as soon as they are discovered. There should be conversations between the developers, the testers and the product owners about what it means for a test to pass. Developers should also be willing to design the product for testability. The testers and developers should be able to work in parallel so that new features can be developed and tested in the shortest possible time. I hope you found that useful. I would welcome your comments if you have any. Is your experience of Agile testing similar to mine? Please let me know your thoughts, even if it's just a thumbs up or down. Please subscribe if you want to be kept updated.